Hi, in this video we'll begin implementing our file system. So first of all, we'll start with the storage device that we try to implement the storage. But let's just do like a quick overview of the storage device in general. And I'll be focusing mostly on the hard disk. Okay, so this this is a hard disk, right? Like this is like the picture of a hard disk, and over here you can see this plate, and then you can see this arm over here, and this arm, or let me go to a much more a label diagram. So this is the plate, and this is the plate. The plates are actually stacked up on each other. Depending for efficiency, they are stacked up on each other. Then this is the same arm that we saw. They call it the actuator arm. Then the plate. The plate is actually what stores the data, right? So it stores everything as binary digits. So it's all the data are stored here. Then it's the job of the actuator arm to actually read and write. So this point label, the head here, is called the read write head, and its job is to basically because hard disks use magnets. So the job of the actually of the head is to change the current. I don't know if it's current, but change the charge of the plates. So individual parts of the plate can be either 0 or 1, and from that we can represent our data in on the plates. So this is the head. Like this is like a deep down view of the head. As you can see, this part of the job of the head is to either read or write. Just like the same way when you're creating a file, you're writing to the hard drive, and but what happens under the hood is just this will spinning operation. The hard disk basically goes there, changes the magnetic poles of the plates. So if it's facing north, it's positively charged. If it's facing the other way, it's negatively charged. So this is just how binary data from our digital files gets stored on the hard disk. Okay, so let's begin implementing our storage device. So first of all, how do we store our data, right? So my idea is to use a byte array in Python. So if you're not familiar with a byte array in Python it's actually, as the name implies, it's an array that stores bytes, but it's an array, right? It's an array that stores bytes. So this is it. So if we want to get the individual values of this array, it's giving us 72 because 72 is H is in ASCII. 72 is H, ASCII encoding. So if we do E, we'll get a different value. So it's basically byte array is to store binary values, and this in this case is storing the ASCII values. Yeah. So we're going to use the byte array to store our values, and so let me just do a quick example. So let's say we have an array that we want to store 2 bytes of values. If we check this array now, it's all zeros, but we can come over here and do this, do 72, remember? And if we check our byte array now, we have 72. The first byte is now H. Then we can do, I believe E was 101. If we do this, yeah, it's, oh sorry, let's do this. So I wanted to do 1 actually, but 101. Now we're going to see we have E and E, right? So this is how we're going to be storing our binary values, but we're not just going to be storing it in the byte array, because the byte array is in memory after our program is off. I mean, once our program is down, we're going to lose the memory, so lose it. So what we need to do is also store it in a binary file that will keep that persistence. Then for our storage class, we also add methods. One method will be to create, that's to create the file. right? Because again, we want to store the file so that we can use that data later, right? So we can see the file almost like the plates in the hard disk. The, the file is almost like the plates in the hard disk here, right? So that's where we store all of our data, like everything goes there and is persistent. Then that's the first method. Then the other method we're going to implement is the read method. The job of the read method is actually to read from the binary file, and the job of the write method obviously is to write too. So let me just do a quick overview of the whole reading and writing aspects. But before that, let me just also do a quick overview of binary. In general, in binary, 1 byte is equals to 8 bits. So like we saw earlier, our H here, this is H, and this is the equivalent bits of H, right? So while we are storing our data in our file, we're actually going to be storing each of these points here as a byte, not as bits, which is different from what the actual hard disk is doing. So whenever we want to read or we want to write, we'll select a position. So right here, our position is 5 from the point we want to basically take our data from. Then we'll set the size. So here we're saying, hey, we want to get our data from position 5, and we also want 5 bits or 5 bytes of data. So that's how our read write head will be working. Okay, so let's quickly go over the code for this. So first of all, we'll define our init method, and our init method will take our path where we want to store our binary file and the capacity. So if we want our storage device to store 10 bytes, we'll just say hey 10. So that means to be able to store 10 bytes, just like when you go and buy a flash or a hard disk, they're telling you here is 1 terabyte, is 2 terabytes. That's the exact same thing that we can do here. Then we'll implement our create method. Our create method will basically open a file based on where we specified our paths, right? Make it to be writable and binary. That's what the WB stands for. And this point here is where we set our capacity. We're basically saying, hey, our data is going to be times this. So if this is 10, it will say, oh, we have 10 bytes, right? So that's what the self.capacity does. Then we write this data to the file. So we've created the binary, the empty data, but we're writing it to the file. Then the next thing, we just print a message so that the user can know where the file was stored and the capacity. Then let's implement our read and write method. So we start with the write first of all. So just like I said earlier, we have a position, the position where we want to sort of like, we can say like where we want to place our read write head. Then we have the content, what do we want to write? So with this, we also use, we open the file. I'm using Python's context managers. And we say, okay, we want to read plus write. That's what the read plus means. We want to read plus write, and it's a binary file. First, so Python's files have the seek method, which is basically, hey, get me to this position. Then the write method just basically writes, just like writes from that position. So with that, we're actually done with the write method. Then we move over to the read method. The read method does the opposite. It takes in the position and how much data we want, so the size of the data we want. So the same thing, actually, we open the file, but this time we are doing just reading binary, because we don't need the plus, because we're not writing, we're just reading. So we seek to that particular position in the file, and then rather than writing, we'll read it and we get that data. Then immediately we get the data, we can return the data in the function, in our function. So this is it. So the next thing we have to do is basically create an instance of our storage class. So this is like we're manufacturing a new storage device. Then we call our create method, and basically what this create method does, it creates the file. So we're storing all our data in this store.bin I use bin for binary, and we're saying, hey, we want our storage device to be capable of storing 10 bytes. Then we're creating it. So what we did here is we're saying, hey, we want to write 5. We want to set the position at 5, right? And then we want to write hello world right after the 5. Right after we just want to write hello world right after 5. So if we do that, we write. Then we are saying, hey, we want to read, but instead of reading everything that we put in here, we just want to start at position 5, but we also just want to read 5 bytes of data. So that is it. So we just print it. So let's quickly run this program and see what we get. And we get hello, because basically we wrote hello world, but we wrote hello world, but when we were reading, we were like, hey, we want to read from position 5, but then we just want 5 bytes, and H is equals to 1 byte, E is equals to 1 byte, this L, both of them are equals to 2 bytes, and O is equals to another byte. So we can also check our binary file, our store.bin, and if you notice, because of where we were reading from, this very first 5 bytes here are empty because they're binary. The editor doesn't really know how to represent them, but since they are binary, it's just empty. Then this other part has been filled up. So this is just more like when you're working with an actual storage device, some parts will be empty and some parts will be free. So this is just our very simple implementation for the storage device. In the next video, we'll be implementing the block, right? So with the storage device, we're just going to build upon it, right? The file system will now be speaking to the storage device, just like in the real world where your file system is actually speaking to the storage device. So thank you very much. Hope to see you in the next video.